Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 307, I chat with John Carafin of Lytro about his company's new Lightfield cinema camera and its many possibilities. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded June 9th, 2016. Episode 307, Lytro Lightfield Cinema. This episode of Home Theater Geeks is brought to you by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/ecotank to find out more. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geek is John Carafin, head of Lightfield Video at Lytro. Hey, John, welcome to the show.
Hey, how are you doing? Thanks for having me.
My pleasure. Thank you so much for being here. Those of you who are watching live at live.twit.tv and logged into the chat room there, or at irc.twit.tv, can post questions as we go, and I'll pass along as many as I can. So a few weeks ago now, I had on the show Ryan Dam from Visby, who gave us a very good, deep introduction into the concept of light field technology. So I don't want to go there again, but I would like to start this show, by sort of revisiting the key concepts of light field technology, light field photography or cinematography, so that we can then use that as a springboard to jump off and talk about Lytro Cinema. So, John, if you would just give us a brief overview of what light field technology is.
Sure, absolutely. So there's a fundamental difference between a traditional 2D camera and what we call a light field camera. So the way to think of it is that the rays of light, when you capture with your traditional 2D sensor, is allowing the light to go through your lens, and then it converges onto an image plane, then making everything effectively baked in. When you have a light field sensor, you actually have multiple viewpoints. In the case of Lytro Cinema, you literally have millions of lenses inside of the camera that are taking those rays and scattering them back out, thereby actually retaining an in-focus ray for multiple viewpoints. So what you've done now is you're capturing not only the color and the intensity of light, but you're now also capturing the angular information about those rays. So what that allows you to do is actually, through computation, reproject those rays of light and then effectively understand everything about the volume in your scene.
So in other words, correct me if I'm wrong, but you're capturing the color and intensity of the light coming in, but also the direction, basically, from which each light ray came into the camera.
That is absolutely correct. So it's called the 4D function, X, Y, S, T, depending on how you have your parameter set up. But if you think of it, the most easy way is that you are looking at basically a hologram of the world. So if you imagine you can see a hologram, you're hanging down the wall, that is your two-dimensional representation. And as you move around or you physically move in space, you're actually now retaining those angles of light, and that is giving you the depth or the volume of your scene.
So this is somewhat holographic capture. It's not using lasers, right?
That's correct. Not using, well, we do have some lasers, but that's other conversation.
That's another story.
Yeah, okay. I'll talk about that in a minute. But effectively, it is a holographic capture system by the definition of retaining the angles of information. It is not using fringes or anything in your traditional holographic film, but this is, in fact, a digital holographic sensor.
Got it. And what this lets you do is to do a lot of things post-capture. That is, once you've captured the image, you have a wide range of things you can do in post-production that are impossible with traditional 2D capture.
That's absolutely correct. And I can talk for hours about all the cool things we can do.
Well, we only have one, so we'll keep it to 1 hour. So, all right.
Okay, we'll keep it high level. I'll come back for the next show. Just kidding.
Right.
So one of the things that we're most known for is the fact that you can capture your content and then refocus after the fact. So with every light field camera, you have a refocusable range. And as long as your content is within that range, you're able to then, in computation, refocus that image in addition to changing your aperture size. So you can then animate your depth of field, which is something that's really traditionally not feasible with traditional video cameras.
Mm-hmm. Now, we actually have some demonstrations here to look at, and let's take a look at a couple of them. You mentioned refocusing. Let's see, here it is.
There it is. Yeah, so this is actually content from the film that we premiered at NAB. And this is one example when you're seeing it go through the range where the director, Robert, and the cinematographer, David, really wanted to help highlight the anxiety of the scene, where traditionally you would never capture something where you throw your lens in and out of focus, and that makes your visual effects and everything else much more complex. So what we were really able to do is capture everything in that scene completely in focus without a green screen, and we'll go into that in a moment, and then have the ability to animate all of the focus parameters, all the depth of field parameters in synchronization with the virtual cameras in that scene, all as a complete computational post process. And it's identical to as if you had actually refocused your scene on set doing that exact function, but now you can synchronize it with your CG integration and anything else you have to do for that final actual virtual set.
So does that mean that focus pullers are now out of a job?
Not at all. Actually, it's a great question because it actually makes that role that much more important, because now you are setting the volume of the scene. You have somebody that is fully responsible for the focus and for actually ensuring that anything from the foreground to the background is maintained within that actual refocusable range. In addition to the fact that with the actual camera itself, we provide a focus controller that will provide a real-time preview of one particular decision. And that's really important, that the director and cinematographer are able to see at that particular moment in time anything about that one particular decision, and it gives them the confidence of the artistic intent. And from that point, it goes immediately into editorial with that decision, but you still retain the 4D light field, so you know that anything that was performed on set is actually just a metadata keyframe stream, and you can then go back in software and change any of those potential decisions depending on the needs of that production.
Well, we're going to see some more examples of what you can do with this light field technology. But before we do, I wanted to get a sense of the camera that was used to shoot this movie that was shown at NAB, called the Lytro Cinema. And it's Lytro is a company. I mean, we've all heard of Lytro. Many of us have anyway. Used to be focused on the consumer market, right? You made a light field camera for consumers to buy and play with. But the company has recently pivoted from consumer to professional applications, right?
That's correct. So we had released 2 consumer cameras. The first one looked kind of like a little butter stick, a little cubic camera. And that was really the first generation proving out that light field can be accomplished in that market. Then we moved on to a much more fully integrated and high-end and flexible, more DSLR type of a light field camera. That was called the Illume. And that was a really cool piece of technology. And the obvious next step for the evolution of light field was video. And once you get into video with those types of data rates, you're now talking about something that is altogether not necessarily, at least by today's standards, a consumer technology. So as a company, we started looking at and pivoting towards professional high-end cinema and VR capture. So Lytro Cinema is the result of that pivot, where we really are truly looking at what is the image quality that is required, what are the specs that are required to make light field truly compelling for the directors and the producers and the content creators in Hollywood. And that was our first launch. That's what we actually exhibited at NAB this year.
So give us some of the specs, which are quite remarkable, of the Lytro Cinema camera.
Happy to. So it is, in fact, the highest resolution video sensor, as far as we're aware of, ever designed. And anyone out there that might have heard of something that's higher resolution in video, please let me know. You'll save me a lot of time. But it is 755 raw megapixels and can capture up to 300 frames per second. And that is 300 frames per second full resolution. That's not any binning or scaling mode. And we can also achieve full 16 stops of dynamic range.
Wow. That's really amazing. I mean, 755 megapixels. What is that? What is that in a horizontal by vertical array?
So the actual raw pixel resolution is approximately 36,000 by 20,000 raw pixels.
Oh, smokes.
So when people are looking at 4K content capture, that's easy for us. We're happy to do 4K content.
That's no problem.
That's no
But
problem. That's easy.
There is some caveat here. I mean, you're talking raw pixels, but then you have to do all this processing and so on, and the effective resolution is somewhat different, is it not?
That's absolutely correct. So if you were to have a full light field or holographic display, you would be actually outputting that full 755 megapixels simultaneously. When you create the content for a traditional workflow or a 2D flattened image, we've optimized it for 2K output, but we are also able to render out 4K as well. So you do have that compromise that for every one output desired pixel, you literally have hundreds and hundreds of input pixels. And that actually is not necessarily lost, but with that information, you're now gaining that additional computational flexibility in addition to higher dynamic range, higher signal to noise, really than anything that exists on the market today.
Another question that comes to mind is the data rate must be just horrendous.
Well, that's all a frame of mind. I like to think it's awesome.
Yeah, okay, awesome. I'll call it awesome. That's fine. But
so
it must be just huge.
It is. So we can capture up to 300 gigabytes per second. That's a big B.
That's a big B.
That's a big B. And that is what is enabling you to then actually capture that full the holographic image in real time at the highest frame rate. You're generally not capturing it the full 300 frames per second. That is something that is in fact variable. But with that information, we're able to do all the compute on the cloud, which enables you to not actually have to physically have that architecture infrastructure, and the camera comes with everything that's necessary to pull the data off of the camera itself.
So what kind of connections are there between the camera and the storage or even up to the cloud? I mean, you must have multiple HDMI or SDI. I don't know what kind of connections you would even use.
Yeah, so these are actually direct data connections. So we go directly over PCIe. And that's actually a tether that goes to a back-end server architecture, and that has all the processing, all of the data storage, all the data streaming capability. And the tether itself is a 100-meter data cable. So that way you can actually put it in a truck or put it in a data center or somewhere near Video Village. And really the impact of the physical rack itself is really insignificant to the production.
Okay. Rusty Bones in the chat room is asking, why stop at 4K?
So that's all a balancing act. It's a great question. It's not a matter of stopping at 4K. It's a matter of what is the angular resolution that you really want to define. So really effectively, how many rays do you want for each of the output pixels do you want to capture in order to increase that signal to noise, increase that dynamic range, and have a fully represented holographic image. So
that makes sense. Okay, that makes sense. The greater the final resolution that you end up with, the more limited the range of directions that you can represent.
That's correct. It's more a matter of the fewer samples you will have per angle. But it's the same kind of a general concept. So if you wanted to go to 8K or 16K, something like that, you could redesign how these micro lenses are built, but you will sacrifice the angular resolution. So if you wanted, you could just take the micro lenses physically off of the camera and capture a full 36,000K image if you wanted. So that's something that is completely possible, and it's just a matter of how do you want to design the system for the output 2D resolution if you're not as concerned with the full flexibility of the holographic image.
Well, I mean, certainly we talk a lot in consumer electronics about 2K or 1080p, 4K or UHD, And a lot of people are going, oh, 4K is just a step on the way to 8K and then 16K, and it's never going to stop. But I take your point very well that as you increase the final resolution, you're going to be more limited in what you can do computationally after you've done the capture.
That's correct. Or you add more pixels to the sensor.
Or
itself.
yeah, exactly. Or you add more micro lenses and
Right.
make a bigger camera.
Right. Exactly.
Okay. All right. Well, this is really remarkable. One other thing I wanted to make sure was to let everybody know that you can also do 3D.
Absolutely. That's it's a fortunate byproduct of light field because you can take your virtual viewpoint and it's actually defined by what is known as the entrance pupil of the lens. So if you look through the back of your lens, you'll see actually the exit pupil from the system itself. And computationally, you can then change your viewpoint at full resolution to be anywhere within that interaxial position. So with the current system we launched, it's 100 millimeters of interaxial position change, and you can actually rotate and you can do anything you want arbitrarily. So you can go from completely flat to off axis to very, very deep stereoscopic imaging. And you also have a perfect representation of that because you're not using beam splitters, you're not doing 2D to 3D conversion, there's no color correction, there's no disparity correction. It is as if you had two completely perfectly optically matched cameras on set. And that's all something that you can do as a post-process in addition to re-rendering it for different formats. So if you wanted to do an IMAX-specific release or you wanted to do a home theater release, you can actually maintain that volume because volume is dependent upon the projected screen size.
Well, as I've said before, and I'll say again, 3D in the home seems to be dying. But in the commercial cinema, it seems to be going strong. Virtually every movie, certainly all the tent poles and the big name movies that are released are in Real D and IMAX 3D and so on. So, there still is a strong market for it in the commercial space, which is the space you're now working in.
Absolutely correct. It's something that we are excited to help content creators with, particularly because they don't necessarily have to make one explicit editorial decision at the time of capture, which is a huge challenge in terms of how does one shot cut to the next, or how do you actually set the scene, or how do you use the camera separation to help tell the story. Although you do need to make sure you're thinking about it at the time of capture. It's not changing the way or changing the workflow on set. You still need to be conscious and aware of it, and then you can also preview that at the time of capture. But it does really help mitigate some of that anxiety of, is it too much parallax? Is it not enough parallax on set?
You can figure that out later and optimize it.
That's absolutely correct.
Yeah. Well, what about dynamic range? You said 16 stops, and I went, whoa, man, that's some serious dynamic range right there.
Yeah.
Tell us a little bit about that.
Absolutely. So the thing that's really interesting about light field is that you can actually sample the pixels in very different ways. So even though you may have a lower bit depth that's reading out from the sensor, which is actually an advantage because of the data rates we're talking about, you can sample simultaneously multiple exposures within the same frame. You can do that with also different color filters and expand out the actual color gamut in addition to the dynamic range without sacrificing anything or having any temporal artifacts. So even though you're capturing at one specified bit depth, it is actually much more expanded in terms of the output 2D image that you produce. Even in the lab today, we have a lot of really cool things that we're doing that actually expand it even beyond 16 stops. Wow.
What about the bit depth of the data? What are you capturing and what are you outputting? What can you get to in terms of bit depth?
So today we're doing 12-bit log, and that is something that is variable and flexible. So you could go down to 10-bit log. You could do 8-bit log if you so choose. That's just a parameter in the camera. We always recommend the highest bit depth possible, of course.
Sure, of course.
But that is something that is independent of the dynamic range due to the way that you can actually expose those multiple exposure or the integration times within that same frame. So from the data sensor itself, we are pulling off 10 or 12-bit or whatever the director and the DP wants. In next future generations, we'll actually be able to go well beyond that.
But then you're converting that, you told me offline, to 16-bit.
That's correct. So due to the way that we're processing, just because of the data as it comes off of the sensor, you do all the computation, then we're converting into 16 float. It's a 32-bit floating point computational environment. But the data itself is stored as a 16 floating point file.
Mm-hmm. Mm-hmm. Okay, so we've talked about the camera. We've talked about its capabilities. Let's go back to seeing some examples of what you can do with this technology. We took a look at one. Let's take another look at it right now, just so that we have it in this set. So slide number 14, which is changing the focus post capture, as we say. So here it is, and the director decided he wanted to. And this is a little short, I guess, that you guys made as an experiment or as a proof of concept kind of thing.
It was really the first launch of the technology. So we wanted to not only show technically what it can do, but use it for creative purpose. So Robert and David, the director cinematographer that we worked with, really were pushing the technology to the limit and using it as a creative tool. And so that was something really important to us, that we wanted to release it with the launch of the technology, a physical use of it as a storytelling device, and not just something to show some technological features.
Sure, sure. And so in that particular case that we just saw, there was a soldier. He was in quite a bit of anxiety. And so the focus kind of went in and out to, I guess, enhance that effect, that feeling.
Yeah. And in the adjoining cuts, you will see that it goes out of focus in other shots. And then you'll see that everything comes into very sharp clarity in the next cut after this. So it was really a good bridge in the edit. So we actually hold what we call a light field editorial or light field supervisor session, where we allow the director and cinematographer to dial in the actual shots in the actual final edit. So that's something that gives them really unprecedented control over the material itself. And they really are, it's actually kind of fun to sit in on these, because they do things that they normally would have never even thought of on set. And it gives them the capability of really refining the story, where maybe something didn't cut well. It actually becomes a really seamless cut after you go through this process.
Mm-hmm. Another example is slide number 16, which is changing the depth of field after the fact. And this is another really interesting thing that you can do. Check this out. Tell us what we're seeing here.
Yeah, so this is a shot where it's actually the same person that you saw as a soldier. This is him as a boy at the beginning of the piece. And what you're looking at the beginning of the shot there, where you see the ball is the only thing in focus as he pops up, is the equivalent of an f.3 aperture. And what I mean by that, that's a lens that physically cannot exist. But with light field, because we understand how those angles of light are actually being acquired by the lens and then also being represented to the sensor, we're able to then reproject the rays in ways that defy the laws of physics of traditional optics. So a 0.3 lens, and again, if anybody knows of one, please let me know. I'd love to buy it. Save me a lot of time.
If you could buy one, it would be mega expensive.
And arguably impossible to build, just because that size optical element is very difficult. And if you are a focus puller on set, trying to maintain focus with a field that's within literally millimeters is almost impossible without some other kind of mechanical and actual computational elements in the system. So that is the first aspect of it, that you're able to create lenses and create a sense of presence there that is such shallow depth of field that from a creative storytelling standpoint, it is directing the viewer's gaze, in addition to the boy that's in that shot, to only be looking at that one object. And that's a really important element to the story. And then you'll see after that fact, we actually animate the depth of field right here, where everything goes into focus. And that's something that if you wanted to try and do this with a traditional camera, trying to animate your depth of field means you have to then change your F number at the same time as changing your ISO or some other type of variable density filters. And that's just not something that's practical unless it's something that's has a computer backing it and actually producing that effect. So that with light field is just an arbitrary decision. It becomes a virtual camera that you set all of the animation curves, and then you can refine it just like you would do with any other CG virtual camera.
Rusty Bones in the chat room says, think of the creative tools this will give director, cinematographer, and editors.
Totally agree, and really happy to hear that. That is our goal, is to provide a new set of creative tools that really help make the final film better.
Yeah, exactly. The next example we have is called Depth Screen. It's slide number 19. And I'd love for you to tell us what this is, because this is really, really cool. So let's get this image up on the screen here. I know Josh is looking for it. Here it is.
So what you're looking at here, we literally took the camera outside of the soundstage and shot in the parking lot. And this is a true, just off of the algorithm process that you're looking at, that we're able to, without the green screen, again, because we have that understanding of where every ray exists in space, perform a foreground background segmentation that is extraordinarily accurate. So if we play this again here, you see that that's literally in the parking lot. There is no green screen. We don't have any specific lighting. And then from that, we're able to extract out the characters here. And that is an artistic tool. And you provide a couple of things in order to allow the artist to select where in space they want that to be performed. But you see in that alpha channel how accurate all of that extraction is on the fishnet, on the hair of the...
On the hair, yeah, I saw that. That's amazing.
Right? And then the other thing that's important to note is with a green screen, first of all, you're in a real environment, right? Or you're not in a real environment, you're in a virtual set, so it makes it more difficult to direct the talent. You also have green spill that is all over everything when you have a green screen. So when you shoot in the practical environment, like we're showing here, you actually now have the capability of doing something that we call light field spill suppression. And what that is, it's a fancy term for, we understand where the pixels exist in space behind each of the subjects. So we can remove any influence from the background color or anything from the light wrap to truly define the edge and the segmentation for everything in that scene. So really what we like to think of this as is it's making every single set into a virtual production set without having the expense or the time to set up a green screen. So just imagine the type of flexibility that you can now achieve by having this additional no green screen capability with the ability to place your characters in any virtual set. So it's something we're really excited about.
Oh, yeah. People in the chat room are too. Loquacia says, yeah, that netting would be very hard to extract. And I agree. Rusty Bones asks, does lighting become more or less difficult?
So it actually becomes easier when you don't have to light the green screen. So this way you don't have to worry about the very even exposure on the green screen itself, which actually does take a very significant amount of time. And 9 times out of 10, you always have issues that a post-production artist will have to go and clean up. And you can actually light from behind now. And that's something that actually is not traditionally all that possible when you have a green screen, because obviously you have a green screen behind the actual talent. So this is actually making it far easier to light than if you had to go into that virtual production set.
Yeah. Now in slide number 20, we can see that same thing we just saw, but all 4 elements of it simultaneously.
Yeah, so this is just so you can actually get a full appreciation for everything at the same moment. I guess you have to hit play individually on this on that slide.
Oh man, they're all 4 separate movies. Sorry, Josh.
We're putting everybody to the total test here, which is awesome.
Total test. Yeah, really, exactly. And Josh is doing a great job. I want to thank him for that. UJ asked, how long did it take to perform this extraction, to perform this, what we're looking at?
So that is a fantastic question. On this particular example, this is almost fully automated. So the artist on this shot literally went in, they were able to define basically what we call the depth volume range, and that is a very quick process. From there, they do very slight cleanup, generating a couple of garbage masks. So this was done within half a day. Very, very quick, and that was a lot of just computational process time. There are other examples, of course, that are much more complex, even though this is a very complex example here, that do take a bit of manual intervention to inform the algorithms how to process. So we always do make sure that we articulate that it is a tool set to enable this. But arguably, without the light field, it's just not something that's possible. That hair netting itself, you couldn't even rotoscope that out. That's just something that is an almost impossible shot, and that is really simple to do with this technology.
Let's see. I had one other question here. Oh, Conky asked, have we talked about the storage requirements for the data yet? And you said that we're talking 300 gigabytes per second coming off the camera. So that's some serious stuff. Up to. Okay, that's an up to. All right. But say for 24 frames per second, sort of normal movie frame rate, at least normal up till now. What are we talking about? Is that definable?
Yeah, it depends on which bit depth, of course. So you're looking at it's around 20 gigabytes per second or less, depending on if you're going into log and going to more 10-bit type modes. And that's actually a very low amount of data for this system. That's something that's actually very easy to stream. So with the camera itself, we actually provide all of the capture storage. So that's not something that the production needs to worry about. And then for post-production, we provide the cloud architecture with all the data storage and all the data processing that's needed. So our goal, obviously acknowledging that it is a lot of data, it's a lot of throughput, is to make that a completely seamless and lightweight process for the content creators. And David Stump, the cinematographer on this film, actually didn't even realize how much data we were collecting due to the way that we built the architecture. So it's something we're really just excited to contribute and kind of act as a bit of a catalyst to really work on new methods for data storage.
Very, very cool. Well, we're going to take a look at some more examples of what this technology allows cinematographers and movie makers to do. But before we do, I'd like to take a moment to thank our sponsor for this episode, which is Epson. Epson's revolutionary EcoTank line of printers for home and office introduce a new age in printing. The new EcoTank ET4550 wireless all-in-one printer doesn't use ink cartridges. Instead, it features an innovative refillable ink tank, earning it the title of CES 2016 Innovation Awards honoree. The EcoTank ET4550 comes with enough ink to print up to 11,000 black pages or 8,500 color pages, equivalent to about 50 ink cartridge sets. You're loaded and ready to print for up to 2 years. Powered by Epson's leading-edge Precision Core technology, it delivers high-speed, vivid colors and laser-quality black text. Plus, auto two-sided printing, a 30-page auto document feeder, and easy wireless printing from tablets and smartphones. All EcoTank printers deliver an unbeatable combination of convenience and value with ultra-low-cost replacement ink bottles. Epson recently released their Creative Print app, making it easier to preserve your Instagram and Facebook photos. Download the app to create personalized photo collages, custom greeting cards, stationery, and coloring book templates. You can also print photos directly onto CDs and DVDs. Be creative on the go. Print from your mobile device to a variety of compatible Epson all-in-one printers within your wireless network. Visit epson.com/ecotank today to transform the way your home, office, or work group prints. For the best combination of ease and value, turn to the new Epson EcoTank printers. That's epson.com/ecotank. And we thank Epson very much for their support of Home Theater Geeks. Epson, exceed your vision. So I'm talking with John Carafin at Lytro about the new Lytro Cinema camera and its amazing capabilities. Let's take another look at another example here. I'm looking at number 22 in the slides that we have here, and we got a few little video clips to show you. So light field camera tracking. Tell us what we're looking at here, John.
So this is actually a whole collection of different technologies built into the light field system. So first, you're looking at the live plate that, on the top left there. So you see it's literally launching a confetti bomb, which, by the way, anecdotally, the director and the cinematographer surprised us with, so that was fun. But this is literally set up to be an absolute worst-case scenario. You can see there's a grip literally walking behind. There's no green screen. It's a very terrible gray thing that's in the background there. We left all of the set pieces, all of the gear in the set, but what we're able to do with a combination of the active scanning that's built into the system and then the dense scanning from the light field itself is, even though you have all of this random noise, meaning the confetti here, you can generate an automated camera track of the actual camera position. And this is something that's done on quite literally every single visual effects shot in order to integrate CG objects into the live action world. And this is something that is a automated process when you get the actual data from the light field and from the camera itself.
Wow. Oh, well, certainly falling confetti is very difficult to encode. There's no question about that. But boy, looking at the grip behind there with a ladder, he's like just walking behind the action of the scene, and see another ladder somewhere else. It's really quite astonishing to see the level of problems, shall we say, in that shot. And I believe also 23 has the next step in that process.
That's right.
Let's take a look at that.
Yeah, so what you're looking at here is actually the finished shot. So you were just looking at how you had that confetti bomb. We're able to use the depth screen to extract out all of that confetti and then put multiple light field and virtual sets into the single piece. So when you're looking at this, you're seeing the result of that silhouette layer is in an individual light field plate. You have the groom and the bride, and then that trellis, which is a separate light field plate with a different camera motion, true camera motion. You have all of the confetti that is extracted out, and then we have a CG set extension for the grass here, the grass and those lines. The lines are actually a storytelling element. And then obviously you have the virtual background with the clouds and everything that looks pretty in the horizon there. These are all integrated with relatively very little artist intervention because we have the very accurate down to the subpixel level camera track, in addition to all of the depth extraction from the confetti itself. And we can do a final composite to make up that actual shot with really none of the challenge that you would have traditionally had for a 2D film. So obviously you would have not shot it like that had you actually captured the scene with a green screen and everything else. But we really wanted to highlight just the level of challenge that you're able to accommodate using light field and by automating many of these processes.
Now, you mentioned that the background was dropped in later, and we saw an earlier example of that, of not needing a green screen in order to place your characters in another environment. We know that many movies, most movies even today, have a combination of live action and CG with different proportions thereof. In many cases, it's mostly CG. I'm thinking of The Jungle Book in particular. I don't know if you saw that one or not, but that was like, one kid in live action, and the rest of it was all CG. Does light field technology, the Lytro Cinema camera, make that an easier process?
Yes, absolutely. So if you can think of the one character in that particular example for Jungle Book that is shot against a green screen, they're making very definitive camera decisions for that piece. And they're looking at it, generally speaking, they had some real-time preview to actually calculate the camera track, and they have some of the CG objects that the director is able to see on a screen and just generally see roughly what that composite will look like in real time. But you are making definitive baked-in decisions. So you do have defocus for edges. You do have different things that are locking you into one creative decision. Whereas with light field, when you extract that element out first, you can be in a real environment, obviously, because you can extract that out without the green screen. And then you can make all of the virtual camera decisions as the CG process, as opposed to making the camera dictate what the CG team and what the integration needs to do. So that's something that actually adds quite a bit of creative flexibility. So the easy way to think of that is you now have, from the live action capture, a true virtual camera. And you can rephotograph that in any number of ways without compromising the way that you want to actually capture on set.
Got a couple questions in the chat room here. I Am Special asks, can you change the light source in this process? So,
fantastic question. So we do generate a normals pass and a surface coordinate pass just as part of the metadata of the light field itself.
Holy smokes, you better define what those mean.
Oh, sorry. Again, I'm a geek, so I apologize.
Hey, we're all geeks on this bus, but I still want to make sure everybody's on the same page.
Sure. So the normals is essentially the direction of the ray of light, so that you would know if you place a new virtual lighting source in the scene, how would it physically hit and reflect off of that surface. And then the actual surface is the XYZ position, or essentially think of your pixel placed in space, and you need to know that for depth and volume. And those two elements combined allow you to place a new virtual light in your set. The one got here is it doesn't give you the surface material. So you don't know unless an artist goes in, which you can do, but you don't know, is it reflective, is it Lambertian, or what type of a material are you physically lighting? There are other technologies. There's something called a light stage, and Ryan may have talked about that. That's some really cool work that does give you those surface material properties. But this is something that gives you much more dense information about the scene itself and the video, obviously, which is much different than really any other technology out there. So you can relight, but if you have bad lighting to start, we always like to make sure that we're not replacing the function of the team. This is something that you can do to further augment like a color grade process.
So you really would want to start out with good lighting to begin with.
That's correct. So if you have a bad shadow somewhere, you can fill that shadow virtually, but the shadow is always baked into the image itself.
In fact, this brings up Muchacho's question, which is, would this technology work in a very dark scene or like in a cave?
So absolutely, you can do that. You need to make sure that you have enough light to saturate the sensor, just like with any other camera. This first generation does have a bit more light requirement just due to the optics itself. And that is something that goes away in the next generation of the technology. But you could shoot in a cave if you wanted, as long as there was enough lighting on whatever object that you're looking at. It would be optically and from a sensor standpoint exactly as if you had captured it with the 2D camera with the same sensitivities.
And I guess we're talking about pretty sensitive already, and you're saying that the next generation will be even more so?
Yeah, close to a magnitude more sensitive. So we're doing some pretty cool stuff in the lab.
Yeah, all right. Creamy Corncob has one more question about the storage requirements. He asks, are we talking terabytes or petabytes of storage, say for a 2-hour movie?
Oh yeah, you're definitely talking about petabytes for your film, and that's something that is again built directly into the camera architecture. So it's not something that is adding storage requirements as long as you're processing and storing on the cloud and the actual onboard camera architecture itself. But traditional cinema films are used to having hundreds of terabytes to support the actual film itself. There's just a lot of visual effects. There's a lot of post-production. They maintain all the multiple iterations. They frequently will store everything as raw 4K content. So it's not outside of the realm of what they're traditionally doing. It is just that much more bandwidth to maintain the full light field throughout the entire production pipeline.
Well, you must need a serious internet connection to do all this in the cloud.
That's correct. Yeah, you're talking about dedicated fiber lines, and those are commercial lines that Lytro basically sponsors in order to push the content up to the cloud.
Let's see. Emily the Strange asks, so is everything needed to do these shots, is it in the camera, or is it designed for certain photo imaging software? I'm sure you must be using like custom software, right?
It's a great question. So we give you a real-time preview on set, so all that's built into the camera display. But from a post-processing standpoint, we're really sensitive to not giving new tools. So we've directly integrated all of the light field processing into existing visual effects software packages. So we have everything as a plugin into Nuke today. Nuke is a kind of the industry standard for visual effects compositing. And then we're simultaneously working on the API in order to release with additional software packages in future releases.
Okay. We have one more little video to show, and that's number 24. This is automated contour tracking, which is related to what we've been talking about up till now. Yeah,
so this is another example. We like to always show this confetti because it's a really challenging.
It's really challenging, yeah.
So we like to, again, geek out on that. So what you're seeing here is an artist would go in, and this is a traditional rotoscope process. Only in this instance, what you're looking at has been fully automated. So the artist goes in, they identify on the first frame the outline of whatever they're looking at, and then the algorithms through the light field, through all of the active scanning, are able to, even with all the noise of the confetti and everything else going on in the background and the foreground, can completely automatically propagate through the scene. So this is something that we're really excited about as well. And on this particular shot, we didn't actually use it for the full bodies. What we actually used it for were the feet. And that's because when you do the depth screen, the feet are actually touching the ground plane. So you use this now to further segment that and allow for the set extension of the grass plane that you saw in the final shot.
Mm-hmm. Oh, I see. The red and blue stripes that they're standing on are there in this shot as well as in the final shot. That's
correct. Actually, in the final shot, it's completely virtual, and that's to allow for different planes and allow for all the different lighting things that the director and the cinematographer wanted to achieve. And then on the edges, instead of it being just a platform, it actually has the grass set extension. So that is all completely virtual, where you have the camera track that allows you to do basically the integration without having to do any other manual effort there.
Mm-hmm. Mm-hmm. Well, next we have some really interesting, super creative applications here. I'm thinking of number 26, variable frame rate and shutter angle. This is, when I saw this, I went, whoa, Nelly, that's amazing. Check it out.
Yeah, so one of the things we shoot in something we call the high bandwidth mode, and that starts at 120 native sampled frames per second. But what that gives you the capability of doing is, just like with focus and depth of field, you can now use the actual shutter angle and the frame rate as a post-production process. So what? Now
let's first of all let's define shutter angle.
Thank you.
What frame rate is. Yeah, it's all right. Frame rate, we know what that is. It's the number of frames per second that's being shot. But the shutter angle, not everybody might be familiar with that term.
Yeah, so the shutter angle is a term to the old film mechanical cameras, where you would literally have a spinning disc that would define what percentage of your frame rate is actually capturing the light and which fraction is in the dark. So for example, if it is 360, that means it's fully open. So the entire 1/24th of a second is actually capturing all of the light. Or if you did something like a 180-degree shutter, that means you're capturing half of the time in light. So you think of something like Saving Private Ryan, which used this as a storytelling element that they shot with a very narrow shutter angle in order to create this very stroby, very gritty action. So on a still camera, when you look at your shutter time, if you're doing high-speed action photography, you're using a much shorter exposure time. And then if you're doing things that you like the motion blur, you want to let the actual motion have some different characteristics, you can use a much longer exposure time or much longer shutter time. So that's something that is traditionally used in film as part of what is known as the exposure triangle. So you have the exposure, the integration time, you have the ISO, and you also have the aperture that all interrelate to create one final aesthetic in your image.
And by the way, just for those who don't know, who might not know, ISO is the sensitivity to light that the sensor is exhibiting, and in modern cameras you can change that, obviously, and clearly in light field camera as well.
That's absolutely correct. So the cool thing that you can do is, because this is light field and because you can do all these things computationally, you remove that necessity to even worry about the exposure triangle, and everything becomes, with that one exposure you captured on set, a computational process. So that means I can change the shutter angle, or meaning you can change the amount of motion blur. You can change your frame rate. So if you want to release for 24 frames per second traditional cinema, or you want to re-release for broadcast at 30 or 60 frames per second, if you want to do a high frame rate release, you can do that and maintain the same creative intent that you had generated in that frame, even though you're arbitrarily deciding on a different frame rate itself. So that's something that is now both a distribution concept as well as a creative process. And you can actually even go beyond 360 degrees, which is kind of crazy when you think about a traditional camera. In one of the examples that we had in the film that we premiered, you can actually go, and you can see it here, up to 720, up to 1440 degrees, which means you have traced that ray over time across multiple frames, and you can create these very dreamlike effects as a camera parameter.
So basically, let me make sure we understand what we're looking at here. On this little clip of the pool, the cue ball moving, you're changing the shutter angle so much that it's becoming very, very blurry and then less blurry. So you're changing the shutter angle as you go.
That's correct. In addition to the actual frame rate. So you see
and
that
the frame rate as well, yeah.
So you see at the beginning, we start at 24, and you do a time ramp up to 120 in order to slow down time. And that's why you see the ball literally just kind of floating on the table there.
And then the next clip we have is 27, another creative use for variable frame rate and shutter angle.
That's right. So here, this is actually from the film that was premiered. You see in the first example, that's just the soldier getting hit and falling out of frame. And then here you see that we actually animate to a 720-degree shutter angle. And that was a creative, intentional use, because in the first time when he falls out of frame, it's very anticlimactic. And here you're able to actually, again, use this as a storytelling element to really accentuate the drama of that scene. So it's something that we were really excited to give the director and cinematographer the full capability to do this in the editorial environment, and really make some choices that otherwise, well, not only are impossible with traditional cameras, but would have been a relatively time-consuming visual effect.
So I got a couple more questions from the chat room, and thank you, chat room, for coming up with such great questions. Creamy Corn Cob is asking, so shutter angle is more accurate with higher frame rate? I'm not sure I understand that question exactly. You can have shutter angle, you can have any shutter angle with any frame rate, really, can't you?
That's correct. I think maybe the question, and correct me if I'm wrong, is more about the accuracy of your edge detail, perhaps, because with a very narrow shutter angle, it's not necessarily a matter of getting more accurate information. What you're actually doing is making everything almost like a freeze frame in time. So if you imagine that if you had the smallest possible shutter angle that the camera could handle, that defines the most sharp and lack of motion blur image possible. So really going back to a more of a virtual production environment. So it's we capture in a higher bandwidth mode to enable us to resample the light field in many different ways. And that's how we're able to do all the computation to variabilize the frame rates and the actual shutter angles itself.
Rev Danomite asks, what does Lytro do for bullet time effects? Like in The Matrix is the most famous example with Neo dodging those bullets. Can you do that?
So it's a great question. So you are limited from a perspective shift to the actual what is known as the entrance pupil, so the lens diameter itself. So you can do bullet time within that lens, or if you set up an array of these, you can actually do far fewer cameras, and they are built on a completely global trigger system, so you can synchronize any number of cameras that you want, and then create that entire wraparound bullet time effect with very little algorithmic interpolation in between that you would have traditionally had to do with any other form of regular bullet time capture. So it's something that a lot of directors and studios have really been excited to experiment with.
Yeah. Emily the Strange is asking, can this camera be used for animated films like DreamWorks? I would think maybe stop action it might be useful, but computer animated movies, you don't even need a camera at all.
So it's a interesting question. So from a technical standpoint, stop motion animation is fantastic. And there's when you think about the challenge of having a very small set and what the image actually ends up looking like due to the optics, everything tends to look very miniature. And with light field, you can further accentuate how miniature the set looks, or you can expand out your depth of field and make it feel much more real, or basically it'll have the same characteristic as if it was a real life-size object. For animation, what we're actually able to do is provide basically a light field camera rig to animators and into the CG composite or the CG environment, so that for a full film, if you wanted to do a full CG animation, you could render it out as light field and then gain these post-production effects without having to go back and re-render anything. Although you do have that virtual camera in the original CG content, so you can then animate that and change those parameters however you want. But as an image format, if this is how you render it out, you do maintain that full flexibility in the final editorial process without the necessity of going back into the virtual environment. What's probably more relevant, and I might be misunderstanding the question, but what we also can do is for the live action visual effects shots that have integrated CG objects, you render out the 4D light field. We provide all the tools to do this so that you can do all of the compositing with the live action 4D information in addition to now the rendered out CG information. And now you can refocus everything completely seamlessly together because you are compositing everything as a light field. So those are all the cameras and tools. Go ahead.
Yeah, it seems to me, though, that you could simply, not use the camera at all and just use the software to completely render an entirely CG image as a light field and be able to do these sorts of things on a completely computer-generated image. Couldn't you do that?
Yeah, absolutely. So once you're in a fully CG environment, if you don't have any live action integration, that virtual camera now has any type of virtual decision that you would like to make. And that's the beauty of the computer-generated pipeline. But once you render that information into a two-dimensional image, you have fully baked the light field out of the content. So you don't have the ability to do that unless you go back into the CG software and re-render the content.
Creamy Corncob asks, so is it safe to say green screens will be a thing of the past in the next 5 years or so?
Well, we would never want to make any assertion like that. We're very excited about how it can contribute to making production more efficient and providing new creative tools without changing how things are currently done. So you may actually want to capture with a green screen and a light field. That's not something that is impossible, but we like to think of these capabilities really facilitating the ability to not necessarily require the green screen on set anymore.
Rev Danomite has a good question here. Would love to know, what can Lytro do for live TV? He says, such as some of the wacky tricks that they do on some late night talk shows.
That's a great question. So light field does require quite a bit of computational post-processing.
Yeah.
So with live broadcast, it can be done in a live methodology. That's not really the current focus of what we've built. But you do see in our on screen when you're capturing live, you are making one particular decision. But if you do, let's say for sporting events, if you want to do instant replay, then it gets very interesting because perhaps maybe they want to slow things down. Perhaps they want to then refocus on a different part of where the ball is on the actual field itself.
Good question. Yeah. So you see it in one view, and then you go back to the instant replay, and you want to look at it from a different perspective or focus on a different thing.
That's correct. So that's something that if you just have a regular lens, you have to do things that you may miss something in the shot. By capturing with the light field and then having it on the instant replay, then you do have the ability to go back and figure out what you really want to look at. So if you're really trying to scrutinize where the ball is on the field, this gives you that kind of really interesting or scientific capabilities.
Reverb Mike is asking the inevitable question. What is this going to cost? What is this going to cost to buy or rent even? I mean, that's probably not a fair question at this point, but I mean, even an order of magnitude. I mean, are we talking hundreds of thousands, millions of dollars?
It's a great question. So we're actually releasing the technology in the first generation as a rental service model. And again, that's just because it's the first of its kind. We're working with really key partners to make sure we get the technology right. So with the package, when they get the camera, they also then receive all the post-processing, they receive the storage, they receive everything on the cloud, they receive all the support that's required to produce the film itself. And that's something that we have, and there's some press releases that we've had about it, that they start at around $100,000 for the production package. But that comes with quite a bit of storage and processing capability and then the talent from Lytro in order to help support that film itself.
Mike Heiss in the chat room, our good friend, is asking about color space capture. And he's specifically referring to 2020. And this is something I forgot to ask you earlier on. About, what kind of color are you capturing, and can you render it out as P3, say, the current cinema color gamut, or 2020, which is the sort of holy grail?
So, it's actually not a problem at all. We actually support the ACES color space, which is the Academy color space, which is wider than, well, really any colors physically possible to exist. So it goes beyond the actual color gamut. So we can produce and provide what is known as the ACES IDT. So from that information, we can then render into Rec 2020, into P3, into wide color gamut, really any color space that you want. We generally work in a wide color gamut color space. But that is because you have the floating point information, you use the matrices in order to do a 1D or an actual 3D LUT to do the transform between any of that. So we always make sure we're working in that very wide color gamut, and then you only bake out the color space when you go to the final 2D render.
Mm-hmm. By the way, IDT in ACES, Academy Color Encoding System, IDT stands for Input Device Transform. And LUT is lookup table, which is a way to transform one color space space into another. Rusty Bones is asking what may not be a fair question. Any negatives to this technology?
It's actually a very fair question. There's so many advantages that you do always have to counterbalance that with the current disadvantages. And today, because it is high data rates and because the camera is quite large, it makes it very challenging to compare it to a traditional cinema camera. But we are simultaneously already working towards the miniaturization of the technology to make it truly hand-holdable and portable with zero tether that'll actually be all onboard processing and onboard storage. But that is the downside today, that it's a large camera. It's bigger than really. Well, it's like the first generation of any large camera that you've ever seen. And then the miniaturization truly does become just an engineering effort, and that's already in progress.
Right. Okay, well, the Macintosh has asked a great final question, which is something that I wanted to touch upon here. We're almost at the end of our time, but he wonders how this might be used for VR, virtual reality.
That's a great question. So we actually have another product line that we have announced called Lightro Emerge. And that is something where we are sampling the light field in a full spherical 360 degrees in order to retain those angles of light. And the goal here is that you want to retain the sense of presence, whereas traditional VR capture is taking an array, some number of 2D cameras, and then they stitch those images together. What we mean by stitching is they take image 1, and then they find a seam line between that and image 2, and then they create a spherical UV map, or basically you create a sphere, and then you projection map onto that sphere itself. And in that process, you have completely lost the light field. So as you are moving through any of the headsets that you're wearing with a traditional VR image, you can move around it, but you can't actually physically see parallax. You can't move in space forwards, backwards, left, right, up, down. With light field, when you retain those rays of light within that predetermined volume, you now have a full 6 degrees of freedom. So that's one of the things that we are really excited about light field contributing to VR and to AR. Fundamentally because you are retaining and you are reprojecting those rays to give you that really interactive experience with the content that you capture.
Well, this is very interesting because I recently attended a SMPTE meeting, Society of Motion Picture and Television Engineers meeting about VR, and they were saying that if you're shooting live VR with one of these spherical cameras, kind of normal capture cameras, then that's the only perspective you have. You know, you sit there and you're where the camera is, and that's all there is to it. Are you telling me that you can, with a light field camera, you would be able to then move around the environment more than not at all?
That is 100% correct. So it's determined by the size of the acquisition system that determines the volume. So in the first generation, and you can see it online on our website, it's almost like a beach ball of volume. So it's designed for the seated experience. So if you want to then get up and move around the room, that is something that is you need a much larger volume to do that. But it's the same principles. You could do that with a larger capture space.
Mm-hmm. Good Sound is asking, what types of lenses are available? Zooms, primes?
I assume that's referring to the cinema system?
Back to the cinema system, yeah.
Okay, great. So currently we have one prime light field lens that is being launched with the technology, and we're already working towards an entire set of custom optics. The reason for that is because this is a image plane that is unlike anything else that exists at least that, again, we're aware of today. We can tell your audience that it is actually a half of a meter wide is the imaging plane. So you compare that to your traditional 35 millimeter sensor, and we are talking about literally it looks like a monitor. And that is that is how we're able to accommodate such high resolution, such high bandwidth. And that's not a limiter of the technology. That's actually something that is in the miniaturization process to get to a much higher density and make it into something that is really small. But in the meantime, there is really very few lenses commercially that exist today, if any, that support a meter-wide image circle. And so for that reason, we have our own design for custom prime lens optics.
Mm-hmm. Rev Danomite is asking, do you know, is this being used on any TV shows currently or any projects that we might know of coming out, or maybe you can't talk about that?
So as much as I would love to be able to talk about that, unfortunately, there's a lot of NDAs that protect a lot of that information. So I can't go into that. But at when we have our commercial launch, we'll be able to identify a lot more information.
And when will that commercial launch be?
So commercial launch occurs, we have an alpha and beta through the end of this year. And then between the end of the year into Q1 next year is the commercial launch.
So we'll see some pretty big news at NAB next year, I would guess.
That is our goal. Absolutely.
Fantastic. Well, I want to thank you so much for being here. It's been a fascinating hour and great questions from the chat room and great answers from you. Thank you so much for being here.
Thank you so much. Everybody on the forums had fantastic questions and just really appreciate the opportunity.
Great. That's John Carafin, head of Light Field Video at Lytro. Boy, oh boy, we dug pretty deep, got pretty geeky here today. So thank you very much for that. If you want to find out more, go to the Lytro website, which is lytro.com, Lytro.com. You can always find me, of course, at avsforum.com. You can email me at scott@twit.tv. And you can follow me on Twitter at htgeekscott and at avsforum. You can always find previous episodes of Home Theater Geeks right here on twit.tv/htg or on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Terrence Huntington, a film composer who also happened to compose the new theme music for this very show. So I'm really, really looking forward to talking with him about that, about his other projects, and about his home theater, which was featured on AVS as a Home Theater of the Month. So it's going to be a great conversation. I do hope you will join us for that. Until then, geek out.